In this video, I'll go through the design standards that we need to comply for the design of water supply system. Engineering design should comply with the requirements of local standards, specifications, and drawings specified by the council and other relevant authorities. In terms of water distribution system, we'll focus on the hydraulic requirements that are the pressure requirements, fire flow requirements, maximum and minimum velocity, and so on. There are other requirements as well, for example, easements, minimum pipe cover, but we'll focus only on the hydraulic requirements in this video. For the design of water distribution system, the first thing we need is the quantity of water. Council guidelines would provide average daily demand, as in this example, 360 liter for EP per day. This average daily demand can be given in terms of EP or ET, but you can convert EP to ET and ET to EP. The conversion ratio is also provided in the council guideline. There are other factors that are required for the design of the system. For example, mean and maximum flow, peak hourly flow, maximum daily flow, and so on. In guidelines, you'll get only the average daily demand or average daily flow, and you'll get other relevant factors. So what is the peaking factor? What is the value of mean day maximum factor? And these kind of factors are also provided on the guidelines. The occupancy ratio of residential area, non-residential area, this information is also provided. So when you design an actual water supply infrastructures, you need to use these values provided by the council. So all these values are required in order to finalize your design flow. Now let's look at the pressure. Pressure is the main criteria for the water supply system. There are different types of pressure, such as minimum operating pressure, absolute minimum pressure, maximum operating pressure. These values are different from council to council. Let's look at the minimum operating pressure. The minimum operating pressure should be checked at the highest elevation in the ground, because it is the elevation where you get the lowest amount of pressure. So when you take the minimum operating pressure, the water level in the reservoir should not be less than 1.5 meters below the top water level. So that means when the water level in the reservoir is 1.5 meter below the top water level, the pressure at the highest elevation should be at least 22 meter. This 22 meter value varies from council to council. In some council, it is 20 meter or 21 meter, and so on. So, but this is not the exact value for all. So it depends on the council requirements. Next one is the absolute minimum pressure. It says in only some isolated high areas, the absolute minimum pressure can go up to 16 meter. Okay, so the minimum has to be 16 meter. Even in the some isolated high areas, you have to provide at least 16 meter of the pressure. But it is only on those isolated areas only. What about the maximum operating pressure? It shows the maximum operating pressure has to be not more than 80 meter, and that is at the lowest elevation. So you can see here, you may have noticed that the maximum operating pressure is the one that you need to check at the lowest elevation, and the minimum operating pressure you need to check at the highest elevation. Let's look at some other information. Trunk mains are expected to have higher pressure than reticulation mains. That's one important information. The pressure we discussed in this video is about the reticulation main. And these reticulation mains are to be sized and interconnected to provide sufficient redundant capacity. That is to allow for interruption of flow from one direction. So when there is a maintenance, then you can supply water from the other direction. Similarly, uh, there is a minimum nominal diameter specified by the council, and that is 150 millimeter. Even though the requirements when you do the design and your calculation shows the minimum diameter is 50 millimeter, 50 millimeter is sufficient to supply to the properties, but the minimum diameter you need to use is at least 150 millimeter. So even though calculation shows only 50 millimeter, you need to use at least 150 millimeter of pipe. The loop main consists of pipeline constructed between one reticulation main and another to create a loop system for improved service and flow in the network. And one thing to remember, you cannot connect directly from the loop mains. Okay. The last one is the pipe connection from reticulation main to the water meter is the property of the council. So you need to make sure that is when you design the system, you assume that the pipe connection from the reticulation main to the water meter is the property of the council. Now let's look at the location of water mains. Water mains shall generally located along the road reserves or across the areas of public spaces, and it should have these easements. And you can see with the increase in diameter, the width of easement also increases. So let's talk about the hydrant. The primary purpose of hydrant is to draw water for firefighting. The spacing between the fire hydrant is specified by the council guidelines, and in urban areas the maximum spacing is about 70 meter, and in residential area it can go up to 120 meters. But again, you need to look at the values given by the local councils. Now let's talk about fire provisions. This table here shows the information about the fire provisions and also the background demands. When we design our water supply system, we aim to provide water for industrial areas, commercial areas, industries, and other water usages. On top of this, we should also assume there could be a fire in the area. In case of a fire event, we need to draw water from the system for firefighting purpose. The guidelines tells us how much flow is required and during the fire event, and what should be the pressure in the system for that duration. So if you look at a table here, this shows in a residential area we need to draw 15 liter per second for 2 hours. Okay, that is the minimum allowable provision. So this value is the minimum allowable provision, and it says consultation must occur between the service provider and the rural fire service to determine the adopted flow provision. So these are the typical values only, and the final value should come from the consultation with the service provider and the rural fire service of that area. So let's assume this is the value 50 liter per second in the residential area, and similarly for commercial industrial area 30 liter per second for 4 hours. So this is the quantity of water you draw during the fire event, and this is the extra flow that it is on top of the normal water supply. Now, to test if our system is capable to handle the fire and also supply water normally for other normal purposes, we need to test our system. How can we do it? Test? We can test our system using the computer simulation. How would you do this? During the simulation, we supply water for firefighting at the rate specified by the council depending on the area with the background demand. Okay, so this discharge plus the background demand. So what is the background demand? So this table here shows what is the background demand for a residential area and commercial area. So for predominantly residential area, the background should be at least 2/3 of the peak hour. The value should be 2/3 of the peak hour. Peak hourly flow, it should not be less than average daily flow. Even though 2/3 of peak hour, when you calculate, if it is less than average daily, then you should use the average daily, because the background flow cannot be less than average daily flow. Now, during the fire, we need to check the pressure. So we put the background demand and then we draw additional water for firefighting purpose. What was the impact of that? Because of additional drawing of water from the system, there will be loss of the pressure. There will be reduction of the pressure everywhere in the system. And you need to check for the residual pressure in the system. That is, minimum residual pressure in the main at the hydrant, it has to be 12 meter, and elsewhere in the supply zone it has to be at least 6 meter. So during the simulation you need to check the residual pressure, okay, and that has to be within this limit. Now, the other thing we need to check as check for the fire simulation is the pressure during the peak hour. So these things we check during the background demand, but we also need to check if the time is the peak hour demand. So that is, during the peak hour, if the fire event happened, what we should do? We definitely need to draw the water from the system. Then at that situation, we need to check for the positive pressure. What does that mean is, if fire happened during the peak hourly demand, then anywhere in the system there should be no negative pressure. Okay, so during the peak hourly demand there should be no negative pressure, and during the 2/3 of the peak hourly demand, this minimum residual pressure has to be maintained everywhere in the area.